Okay, so we're going to look now at absolute values. Now, if we remember, when we do absolute values, and we work with these, when it's an equal sign, we get two solutions, right? Because we have to set it equal to a positive case and to a negative case. So when we solve an equals, we have to solve it twice. So if I give you something like the absolute value of 4x minus 9 plus 5 equals 12. Okay, let's start off with one like this. You should kind of be familiar with what to do. So an absolute value means that we get two different numbers that will make it work. We have a positive number that makes it work, and we have a negative number at the end that makes it work. Now, that doesn't mean that they're both positive and one positive, one negative. It doesn't mean their answers are going to be like that. It just means when you plug it in the absolute value, we have two different numbers that make it work. And if you remember also for these absolute values, what you have to do is you have to make sure that the absolute value is by itself. So this 5 is not part of the absolute value, so that 5 has to be subtracted off because you have to get the absolute value by itself. And 12 minus 5, that makes it a 7. So you have to first isolate the absolute value. Now, once we've got that absolute value isolated, then remember we have two numbers that will make it work. We have the number that makes it a positive 7. We have the number that makes it a negative 7. So now we solve 4x minus 9 equals 7. Or our answer could be 4x minus 9 equals a negative 7. Right? And we have two different numbers that are going to make it work. So you get that absolute value by itself. And once you've done that, then you just simply solve it. So we just solve each one. We add that 9 over. So then we've got 4x equals, now adding together, 16. Divide by our 4. And so one solution is x equals 4. Move that up a bit here. And the other one, we add our 9. And that gives us now 4x equals now minus 7 plus 9, that's a 2. We divide by our 4, and now we've got our other solution, which is 1/2. So the two numbers that are going to make this work are positive 4 and positive 1/2. Those are the two numbers that are going to make this work for us. Let's do one more of the equals, the equalities, and then we'll look at the inequalities. And then we'll look at special cases. So let's look at this fraction one here. So this is what we've got, and we're going to make it equal to 4. Now, what do we know? First off, we need to get the absolute value by itself. Is our absolute value by itself? Yes, it is, right? Absolute value is on the left, 4 is on the right. I need to come up with my two equations. So what are they going to look like? They are going to look like 3x minus 4 over 2 plus x equals 4. And the other one is 3x minus 4 over 2 plus x equals now a negative 4, right? Now you just solve them, and that's going to be it. So whenever it's equals, you just get the two equations and you solve them. Now, I picked this one because you have one like this in your homework, and we need to remember how to solve these. How do we clear the fractions? We simply cross multiply, don't we? So we're going to cross multiply here. So that's 3x minus 4 equals 4 times 2 plus x. The other one, and we'll just split it down here so we don't get mixed up. The other one, when we cross multiply, is 3x minus 4 equals minus 4 times 2 plus x, right? Now we just simply distribute through that 4 and that negative 4. And that is now 3x minus 4 equals, when you distribute, 8 plus 4x. And 3x minus 4 equals minus 8 minus 4x. You should kind of know what to do from here. You just simply solve it. So you move things around, solve it, and we're done. So we're going to move that 4x over. And we're going to add 4 as well. Easy enough here. So that makes it a minus x equals now adding 12. Divide by a negative 1. So we now have x equals now a negative 12, right? Easy enough there. Repeat the process on the other side. So add your 4x. Add your 4. And now we've got 7x equals now a negative 4. Divide by our 7. And now we've got it as x equaling a negative 4/7. And there we go. So there's that one. And let's do one more where we've got a negative and we have to distribute it through when you've got an absolute value equaling another absolute value. So let's do a real quick simple one here. How about x plus 5 equals the absolute value of x? Well, let's make it 2x plus 9. So we're going to try to solve this one. Now we're still going to get our two equations, right? And what are our two equations going to be? Where they're going to be x plus 5 equals 2x plus 9. Nothing new there. What's the other one? X plus 5 equals a negative 2x plus 9. Remember those? So when you have an absolute value equaling another absolute value, the first one you just drop the bars. The second one, you just put a negative in front. And now we just distribute through and solve these. So we'll just work on the left side first, since there's not much to do. Move the 5 over. Move the 2x over. And x minus 2x makes it a minus x. 5's cancel. And 9 minus 5 is a 4. Divide by your negative 1. And x now equals a negative 4. Repeat the process on the other side. Distribute that negative through. And now we'll add the 2x. And move the 5 over also. And that leaves us then with 3x equals now negative 14. And we'll divide by our 3. And our second solution is a negative 14 over 3. And again, this should be review. I know you've done these in previous courses before. All of this section should be a review. Might have been a while, but I know you've done these before. Now, what about a negative? Can we ever have a negative value come out of an absolute value? No. Why not? Because if I try to take the absolute value and make it negative, that can't happen because the absolute value of any number is positive. Right? So if I say solve this one and I say solve, the absolute value of x minus 4 equals negative 5, this is not going to have a solution. And why is it not going to have a solution? It's not going to have a solution since the right-hand side is negative. Because whatever comes out of an absolute value, remember, has to be positive. So whenever it equals a negative, like this negative 5, you don't have a solution anymore. Now let's move on and let's talk about inequalities. And these we're just going to have to graph them on a number line. So there's really not much difference on these either. And these won't take long to solve either. And they're actually pretty simple to do. So let's try to solve this inequality. Now what we're going to do is we're going to solve it, and we're going to get our two pieces, just like we did before. And then we're going to pick one number, usually 0, and we're going to see if it's true or false, and we're going to make the regions according to it. So we only have to pick one point to check, and that's 0, unless somehow it gets 0 on the line. So first off, it's an inequality, and so we're still going to go ahead and get our two solutions. So we're going to break this up into it equaling a 3, and we're going to break this up into it equaling a negative 3. Okay. Nothing new here, just like we did the equals before. Now we simply move that 4 over. And so now we've got 5x equals, when you distribute through, a negative 1. Divide by our 5. And we now have x equals a negative 1/5. Repeat the process on the other one. That's a negative 7. Divide by our 5 here. And we get x equals now a negative 7/5. Okay. Now, when we look at these on the number line, there's only two choices. The two choices are this, and we only have to check one number. So the two choices are true, false, true, or false, true, false. That's your two choices. Never deviates from that. So it's either true, false, true, or false, true, false. Nothing else can happen. What we're going to do is we're going to put these on our number line. Make sure they're in the correct order. Make our regions, just like we did a moment ago. But we're going to pick 0. And let's find out where 0 is at. So 0 is clear over here. 0 is bigger than a negative 1/5. So that's clear on the right. And we're going to take that 0 and we're going to plug it in. And we're going to check it in the absolute value of 5x plus 4 is greater than or equal to 3. So we're going to check it in there. We only have to check 0, and that's it. So these are actually a little bit easier than the ones out of 1/7. So we plug in our 0. We're going to choose x equals 0 here. 5 times 0 is 0. That's gone. So that gives me then the absolute value of 4. And the absolute value of 4 is 4. And is 4 bigger than 3? Yes. 4 is greater than 3, so that's true. Now, they switch back and forth on the sign, so that's true, false, true. We don't have to check any other regions. All we have to check is 0. That's it. Unless somehow you got 0 as one of the points, and then you'd pick a different number. But that very rarely happens. So we can use 0 because it's so simple to work with. And that came out to be true. Now, where do we shade? All right, so let's go back and make sure we shade where it's true. We're going to use square brackets here. And so when I go to write my answer, what does my answer look like? Negative infinity, comma, negative 7/5. With the square bracket, we use a U for union. Minus 1/5, comma, positive infinity. Oh, sure. Sorry about that. Yep, no problem. That was my fault here. Okay, so let's try another one here. And we'll flip the inequality symbol around. So let's try to solve this one. So we're going to try to solve this one again. Now, what do we always have to do? No matter which type it is, first thing we do is we check and make sure that the right-hand side is positive. Is our right-hand side positive? Yes. Okay, so if it's positive, then we got to get the two numbers. That's it. First step we always do, get those two numbers. If it's negative, we have to check things, and we'll do one of those here in a moment. But that 9 is positive, and since that's positive, I go ahead and get my two equations to solve. And so that's 5 minus 4x equals 9, or 5 minus 4x equals a negative 9. And now we simply go through the process of solving this. So we move the 5 over. And that leaves you then with a 4x equals now positive 4. We divide by our 4, and that gives you x equals 1. Easy enough. Repeat the process on the other equation. So move your 5 over. And that's going to give you a minus 4x equals a minus 14. Divide by your negative 4 and make sure you reduce. So negative over negative makes it a positive. 14 and 4 both have a 2 in common, so that's 7/2.
So on the other one, were you supposed to divide by negative 4x on it?
Did I? Oh, my mistake. Yep, sorry about that. Got a little bit of a hurry here. You're right. Sorry about that, Tracy. Yep, so divide by that negative 4. So that's going to make that then a negative 1, 1. Okay. And so you can always check that with that negative 1, because if you plug it in, you should get 9. If I plug that negative 1 in, I get negative 4 times negative 1. That's positive 4. And 4, this positive plus 5, makes it 9, right? And so 9 equals 9. And same thing when you plug in the 7/2. If you plug that 7/2 in, you'll still get 9 again. It'll just be a negative 9. Now we put them on the number line. And we're not going to have to check every region. All we have to check is where the 0's at. And where is the 0 at? In the middle. So don't check them all. You can if you want to, but it's really not needed. All you have to check is where 0's located at. And we're going to check it in the absolute value of 5 minus 4x. is less than 9. So we're going to plug in 0. And 5 minus 0 is 5, and the absolute value of 5 is still 5, and is 5 smaller than 9. Is 5 smaller than 9? Yes, that makes that then true. So, if that is true, now what do we know? All right, we know it's true in the middle. So, the signs have to switch on these. Always they switch. So if the middle's true, then the sides must be what? False. And where do we shade at? We shade in the middle, okay, right here, and we use parentheses. Why parentheses? Because strictly less than, strictly greater than, they get parentheses. Greater than or equal to, less than or equal to, remember, those get the brackets. And so what would our answer look like? It's going to look like minus 1, comma, 7 halves. And that's it. Let's try another one. And then we're going to look at our special cases. I want to make sure we have enough time to go through several of the special cases. So let's do one more of these. And we're going to solve this one. This is another inequality. So we look at it and we make sure that the right-hand side is positive. Nothing else needs to be moved over. If you had like a plus 3, you would move it over first. This one does not. Okay, so all we've got is we've got a 10 on the right-hand side. That's what we want. Absolute value is on the left. The 10 on the right-hand side is positive. So that means we've got to solve it. And we've got to solve it equal to 10. And we've also got to solve it equal to a negative 10. And never, ever change what's inside the absolute value. Those signs stay the same. All we change is the right-hand side. The number on the right-hand side is the only part that changes it all. Now we can finish it. So we're going to add 5. Minus 8x equals now 15 when I add them together. Divide by our negative 8. Nothing reduces down. Bless you. So now we have a minus 15 over 8. Simple enough there. Repeat the process on the other one. Add that 5. So minus 8x equals now minus 5. Divide by our negative 8. Negative and negative then makes it a positive 5/8. Is everyone okay with that so far? Pretty simple to do. Now, put them on the number line. Make sure they're in the correct order. And then, where's the 0 at? In the middle again, right? Could be on any of these. Could be on the edges, or it could be in the middle. In this case, 0 is in the middle, so make sure you locate the 0. And now you simply plug it back in. Plug it back into the original. We're going to plug that 0 in. And 8 times 0 makes it 0. So we've got the absolute value of a negative 5 is greater than 10. And the absolute value of a negative 5 comes out to be positive 5. And is positive 5, is that bigger than 10? No. So that means this is false. So now we've got a false in the middle. So the ends are what? True. And these get square brackets. And what does our answer then look like? Remember, this is negative infinity here, positive infinity on the right. So our answer in integral notation would be negative infinity, comma, negative 15 over 7 with a square bracket. Make sure you see that's the square bracket there. And we use a U for union, square bracket, 5/8, comma, positive infinity there. Okay. Now let's talk about and focus on the special cases. And the special cases are whenever the right-hand side is negative. So the special cases are going to be when that right-hand side is negative. And the only possible answers now that we can ever have are going to be negative infinity to positive infinity, meaning all real numbers, or no solution. So that's what we're going to be facing with. So that's what we're going to be facing. It's either going to be everything or it's going to be nothing. And how we determine that is we check a number. And not check a number. We look at the side and we say that absolute value has to be positive, and we compare it to the right-hand side. So it's very, very easy. Non-calculational. On these, a lot of times students try to make them more complicated. They try to solve it when it's either a true or a false type of absolute value. So let's look at 4 or 5 of these. This is a special case. And the reason why it's a special case is the right-hand side is negative. Now, if the right-hand side is negative, it is either everything or nothing, meaning true or meaning false. How do we check that? Well, we assume that an absolute value gives you out positive numbers, or 0. We're just going to assume that they are positive. And then we check it and we compare it to the negative 9. And our positive numbers, are they smaller than a negative 9? Is that true or is that false? This would be false. Okay, now if it is false, then that means you have no solution. And that's it. When it's a negative number on the right-hand side, it's either everything or it is nothing. There's no in between. It's all or nothing. And we don't have to solve them. We don't even care what's inside. All we care about is making it positive and seeing if it's true or if it's false. Same thing with equals. We did an equals earlier today, right? Right when we came back from break, we looked at a negative equals. And let's look at this one again. Okay, so this one is a negative 10. Well, what do we know? Absolute values are positive. Can positive numbers ever equal a negative 10? Can that ever happen? No. So what would this one again be? False. And if it's false, what does that mean? No solution. There are a lot of these in your homework. We're going to do a couple more just to make sure we have these down. 100%, because they're very important, very easy, and there's some on your exam. Okay, let's make sure I got it right here. How about greater than or equal to 8? Okay, so here's another one to look at. Now, when you first look at it, you might think that you might have to solve it. But in reality, you don't. Because before we do any other operation and start working with these absolute values, we have to make sure that the absolute value itself is isolated on the left. And so that 15, is that part of the absolute value? No. So that 15 then has to be moved over. And that then makes it a negative. And 8 minus 15, well, that's a minus 7, isn't it? And now, because we moved it over, and we've isolated the absolute value, this is now a special case. And what do we know about the special case? Well, we know that this is positive for the absolute value, and our positive numbers, are they bigger than a negative 7? Are all positive numbers bigger than a negative 7? Yes, so that would be true. And true means it's true everywhere. And so then that would give you negative to positive infinity for your solution. Let's do one more, just to make sure we completely understand these and do not try to solve them when they're negative. And what do we do here? Well, same process. We move that 2 over. And that makes it a negative 1 now, doesn't it? Again, all we're doing is solving. Well, this is, again, negative. So that means this side is positive, and our positive numbers bigger than a negative 1. Yep. So what would that then be? True. And so if it's true, then it's negative to positive infinity. What about 0? Okay, well, depending upon what it is, you might solve it for 0, or it might be a true or false. If it's an equals, you're going to have to solve it. But this is actually easier because there's no reciprocal of 0, no negative reciprocal of 0, because 0 doesn't have a sign at all. So if I say solve this absolute value equal to 0, then what are you going to get? Only one equation, right? Because you can't have a negative 0. So this would then just simply be x plus 8 equals 0, and so x equals then a negative 8. Right? So when it's an equals, we don't have to graph it, and you're only going to get one solution because of the 0. Now, if it happens to be an inequality, then you still have to check it and see if it, again, if it's true or if it's false. Okay, now, this is an inequality. So inequalities, we have to actually check them. And let's think about what we know about an absolute value. Well, we know an absolute value is going to come out to be positive, right, or 0. And our positive or 0 numbers, are they bigger than 0? Bigger than or equal to? Yes, they're either equal to 0 or bigger than. So then in this case, this would be, again, true. And what would your solution set be? Negative to positive infinity. Now, we do have one application in your homework, but it's already set up. So question 15, all you have to do is solve this inequality. That is it. And he just talks about these palm trees, and we've got an inequality. All you have to do is solve it. Now, just because of time, we're going to be missing class on Monday, so no class on Monday. That's going to be July 4th. We are going to have our exam on Wednesday. And I have a practice one for us to, a take-home one for us to look at as well. So our exam's going to be on Wednesday when we come back after the break. What can you have on that exam again? You can have 1 page of notes or note cards, just like before. You can have scratch paper. And you can also have a calculator. I do have a practice exam in that packet and a take-home. So this take-home is worth 25 points. I think it worked out well last time. I think the take-home actually helped us do better. So it's very, very similar to what you'll see on the exam. And again, when I make up the exam, I'll mix them up. So there's slightly different questions, but still similar to each other. And I'm going to work out your practice exam and post that online this afternoon. So I'm going to go through your practice exam. I'm going to look at every single question, and I'll work them all out, and I'll post them online this afternoon. So that way you can look at the practice one. That's going to help you do the take-home one. And then we can work out questions on that on Wednesday. So Wednesday, we'll have an hour and 15 minutes to answer any questions that you might have on the practice exam or the real exam before we take our exam. And we're going to, again, remember, start class at about 8:45. This way, most of us should be able to be here by 8:45, or at least close to it. And some students aren't waiting, so we'll just plan on starting at 8:45. I'll be here earlier. If you have questions earlier, I usually get here about 8. So if you've got questions for me, and you have a lot of them, and you want to come early and ask me questions, I'll be here. So I'll be here at 8, all the way until 8:45. When we'll start class, we'll go over more questions also. But that's kind of what we're planning on for Wednesday. So no class on Monday, that's 4th of July. We'll come back and we'll take our exam on Wednesday. And I am going to work out that practice exam today, and I will post the worked out key with step-by-step solutions for each one on Canvas shortly.